All right, welcome to the video where we are just going to nice and slowly discuss how to set up and formulate a linear programming problem. We have a couple of problems that we're going to look at, and we're going to take it nice and easy to get us used to how to think about this, how to translate all these words into a mathematical model. And in our case, it'll be a linear programming model. So let's look first at problem 2.6. So in this problem, let's just first read it. And my first read through, I'm not obsessing about all the detail. I know going in, it's a linear programming problem. I'm trying to identify the objective function first. That is my first goal. And in the process, trying to get an idea for what this problem is about. Not looking at all the detail and trying to remember it during my first read through. Okay. An investor wants to invest $15 million in a portfolio that may include bonds, certificates, treasury bills, and stocks. The expected annual returns are given in the table below. It's over here, unfortunately spanning a couple of pages. There it is. And we'll come back to that. The investor also wants to diversify the investments and has decided maximum amounts for each security. Okay, so the table here summarizes that he's going to make, or she, I don't know who, they are going to make a 5% return on the amount invested in bonds, and they can only invest up to 3 million. And so each one has a return percentage and a maximum amount that they want to invest in that specific instrument. So, in addition, the investor has decided that at least 60% of the investment should be in treasury bills and stocks. I read this, but I know that's going to become a constraint, and that's not my focus right now. But I do glance over it. And at least 10% in bonds. Again, some constraint, not really my concern right now. He's also decided that the sum invested in bonds and certificates must exceed the amount invested in treasury bills. Some constraint, not interested. The investor wants a maximum return on his investments. Now, I'm interested in that. So the return on investment, I want the maximum. There is my objective. Find the optimal composition of the portfolio. And usually, ironically, the things I want to start with come at the end of all the detail. So let's just go right into Excel. You'll see my answers. I just type it in Excel. Why not? So this is, I'll just number it over here, 2.6. And let's begin. So maybe a sentence here to help you. We wish to maximize return on investment. Just words, just to get into the flow of this, right? Okay, I want to maximize my return on investment. Now, in my formulation, the first thing in the model, in the formulation, is my decision variables. So I now think I want to maximize the return on investment, which means I need to calculate the return on investment. What would I need to know to calculate that? I would need to know how much is invested in bonds, how much in certificates, how much in each of these different types. That then tells me what my decision variables should be, and I go ahead and write it. if I can type properly. And I'll say, what was the first one? Let's go B for bonds. Let B not represent bonds. No, that is not correct. B is a variable. B represents a number. In this case, the amount, dollar amount, sure, put a dollar sign there, invested in bonds. I'm going to do something similar for certificates, treasury bills, and stocks, CTS. But to be a little bit more efficient here, I'm just going to copy those over and edit them, make that C. Was that C next? Yeah, C. It's going to be the amount invested in certificates. Just so I don't write the same sentence 4 times, right? Treasury bills. Treasury bills. And lastly, stocks. Stocks. You need, let me just check if it matches perfectly. We need a sentence defining each decision variable because my model will use these variables. The definition of the variables serve as the key, the link between the English language and this mathematical language. That is where I start, even though I might want to write sentences to remind myself what's happening. Not really a part of the formulation, but it's good to write stuff down. Now the next part, it's a 3-part model. First part, decision variable definitions. Second part, the objective function. So the objective is to maximize, now let's give it a name, R for return on investment. I'll make it that, ROI. Where ROI is going to be calculated in a certain way. So have some words, it's okay, but technically row 10 here is the objective function. I do need to say, do I maximize, do I minimize this objective function? How do I now calculate my return on investment? Well, it's going to be, let me write this out, sort of a helping way first, and then we systematically fill in the detail. Of course, I'm tailoring this video to those that do not feel comfortable with this translation process. If you are super comfortable already, this might be too simple for you and you don't need it. This is for those that may need it. So it's the, let's say here, return, I'm going to put it in brackets, return from bonds plus return from certificates plus return from, I'm just going to say treasury bills. I'll write the whole thing, why not? Why not? And lastly, the return from the stocks. Each of those things that I'm investing in gives me a part of my total return. I can then go in and say, okay, what is the return on bonds? Well, it is 5% of the amount that I'm investing. And I'm investing B dollars. Therefore, the return on bonds is 0.05 times B. Whoops, I didn't have numlog on. Sorry. There we go. Just 5. B. Don't need the brackets. You're welcome to leave the brackets. Don't care about the brackets. It's a percentage of the amount. Return from certificates, percentage is 8% of the amount invested, which is C. So return from certificates, let's get rid of all of that. 8% times the amount. And we continue in this fashion. Treasury bills, I do not remember the percentage. It's 13%. Ooh, nice. Wow. 0.13 times T. And lastly, not sure which stocks he is investing in, but it's 16%. Very nice. S. Done. Done. Easy. Can be if I systematically build this up. Now this is, of course, subject to some constraints. Let's list the constraints. This is where the detail is, right? I check from the beginning. If I can slowly scroll up here, an investor wants to invest $15 million. Okay, so that's my total investment. Maybe let's write it over here. Total, oh, can I not type? Investment is going to be B plus C plus T plus S, because that's the total of everything I'm investing, all the four parts together. That has to equal 15 million. Some people here might say less than or equal to, but according to this wording, they want to invest 15 million. All right, it's equal. The total of what they're investing is 15 million. Done. Now you can put this a little closer if you want to. That constraint is done. Then they talk about the types. We've already covered that. Expected annual return, that decides our objective function. We have diversification requirements. First up is they don't want to invest everything in a single type. The amount invested in bonds should cap out at 3 million. The amount invested in bonds should be less than or equal to 3 million. So let's say here, bonds cap. Each one has a cap. Certificates need to not exceed 7 million. The amount invested in certificates less than or equal to 7 million. That constraint is the certificate cap. Have descriptions. It's okay. People think, ooh, I'm doing some mathematical formulation. There can't be any words there. Oh no. No, put words. It adds to the readability of the whole thing. Of course, I want words. So I continue in this way at my own pace. There's no rush at all. Let me just exit that. Exit. Thank you. Bye-bye. So we don't get any weird pop-ups. Treasury bills. Cap of 6 million. The amount invested in treasury bills should cap at 6 million. Is that enough zeros? I hope so. So that'll be the treasury bills cap. Have descriptions so that a month, 2 months from now, you look at this, it makes much more sense because you added notes to help yourself read it. Or whoever needs to grade this question, what if it's a test question? Help them read your answer. Stocks cap out at 5 million. All right, the amount invested in stocks should not exceed 5 million. That is my stocks cap. There we go. Those are the constraints as I am reading them so far. There may be more. In addition, there is more. The investor has decided that at least 60% of the investments should be in treasury bills and stocks. Let's read it again. And pause if you need to think about it. If I'm still going too fast, pause the video. Think about it. What would you do? Don't just sit back, lay in your bed, and listen to me, and then you say, oh yeah, ooh, that sounds good. I would do that too. No, you wouldn't. Not necessarily. Think first. Get verification after. Okay. Investor has decided that at least 60% of the investment, 60% of the total amount, should be in treasury bills and stocks. So we can rephrase this. The amount invested in treasury bills and stocks should be at least 60% of the investments. Unfortunately, the phrasing here is a little backwards, which makes it a little bit more confusing. At least 60% of investments should come from these two types, treasury bills and stocks. So we then say, okay, treasury bills and stocks should be at least, not plus, at least 60% of what? Of what? Of the total amount invested, which is B plus C plus D plus S. I don't need the multiplication there, but I like it. Why not? So that is the 60% requirement. Who knows what to call it? It doesn't matter what you call it. Think about it. Next, at least 10% of the investments, 10% of the total invested amount should be in bonds. Rephrase, the amount invested in bonds should be at least 10% of what? Of the total invested. Call it what you will. Bond requirement. I don't know what to call it. It's just for you. But for consistency, let's put brackets around them all. There we go. We keep going. Also decided that the sum invested in bonds and certificates must exceed the amount invested in treasury bills. Okay. The sum of bonds and certificates must exceed the treasury bills. So bonds and certificates must exceed the treasury bills. What do we call this? I don't know. Bonds, certificate, requirement. Does not matter what you call it. Okay, let's check that. Does that make sense? In the sum of bonds and certificates must exceed, greater than, the treasury bills. Key. Okay, we've clearly reached the end. Then he talks about the objective function, blah, blah, blah. I'm, of course, looking for the optimal composition. One thing's missing, which is my non-negativity requirement. Write that in. Right bracket, yeah. Non-negativity. Boom. There it is. I'll zoom out. There it is. That's my formulation. It's beautiful. Now I don't care what people say, you don't have to simplify these in the formulation. We need to simplify them by moving all the variables to the left for the use in Excel and whatever solver you might use, whether it's by hand or whatever. I have 4 variables here. This is not happening by hand. It's impossible. To graph it, it's impossible. So there's my formulation. You know, we're down the rabbit hole anyway. We might as well practice some Excel as well, right? Why not? I'm going to do it right below here. Easy peasy. How do we set it up for solver? Now everyone has their little bit of color coding that they like to use. It doesn't matter. Let's put the variables over here. It is B. It is C. It is T. It is S. Those are my variables. Over here, I will do the objective function coefficients. And here I will do my constraints. I don't name them here. I should probably. I'm just lazy. I don't want to. If I know what I'm doing, it's not necessary for this size question. Over here is going to be my variable values. I don't know what they are right now. I do put something in just to see if my formulas work, but this is where the optimal solution will be presented eventually over there. Let's go to the objective function coefficients. Well, they're over here. The coefficients of the variables in the objective function. So for B it is 0.05, for C it is 0.08, for T it is 0.13, for S it is 0.16. I like to put the objective function value right there. I'll name this ROI. I like to color it green. That's how I was taught. Yellow is input, green is output. That's just my habit. I'm going to make it a little lighter green. There we go. Let's put a formula in this one. Now you have options here. You can type it in. Sum product, tab to complete, this grouping with this grouping, pair them up, multiply and add, done. I put numbers here because if you didn't put numbers there, you can't verify extra that your formula, Excel formula works. Let's suppose we didn't do that. What else can we do? Excel has a very nice function builder, formula builder. I click on this little FX. I can search. I want to search sum product. Go. There it is, sum product. Double click on that. And it tells me, okay, what's your first grouping? Maybe this one. What's your second grouping? Maybe that one. It also gives a description here. If you don't know what sum product does, we want to multiply this one with this one, 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 and add them up. It's called sum product. Okay, we're done. Easy. All right. Now the constraints. The constraints. Some of them are straightforward. This first one. Actually, maybe we should put these guys over here. That might make it nice. Let's make a nice spacing here so we don't interfere and overlap. Yeah, why not? Let's do that. So, the coefficients for the total investment constraint, 1, 1, 1, 1. I'm going to get an answer there. I'm going to put it blue because I need another color, and blue is a nice color. And then I remind myself that it should be an equal, and it's a 15 million, 1, 2, 3. That is the requirement. We're going to put this formula in later. Right now, left-hand side, right-hand side, reminder of the inequality or equality or whatever it may be. Bonds cap, What are the coefficients on the left here? 1 in front of the B, 0 in front of the C, 0, 0. Some people leave them blank. I like to put in zeros, so I know I've got it covered. It's totally up to you. Less than or equal to is just a reminder. 7 million. Certificate cap. B has a 0 coefficient because there is no B. C is a 1, 0, 0. It is a less than or equal to 6 million. Treasury bills, I just keep going. Those inequalities are all very similar. Oh no, T gets a 1, right? Put the zeros in, don't put the zeros in. Any empty cell, Excel will treat as 0. So my training told me, or did I not do this right? I didn't do this right. Bonds, 3 million. Certificate cap, 7 million. Treasury, 6 million. Ooh, good. My training told me don't leave anything blank here. You don't trust, I don't trust what the computer does with a blank cell. So I put in a 0. You don't have to. Last one. S is there. 1 for that one. And a less than or equal to 5, 1, 2, 3, 1, 2, 3. This time I hope I got the numbers right. Good. We'll scroll down a little bit so we can see more. The 60% requirement, or whatever you call it, it's not looking perfect for Excel, right? Unfortunately not. So we have to clean it up a little bit. We have to simplify it a little bit. I'll just do it next to it. So let me do it in 2 steps. I have T plus S greater than or equal to. Multiply the 0.6 in, I get 0.6B, 0.6 C, 0.6 T, 0.6 S. Now simplify that by moving everything to the left in order B, C, T, and S, right? Because that's the way I have it here. So B first, all the B's move to the left will get me to negative 0.6B. All the C's to the left will get me to negative, whoopsie, just 0.6 C. All the T's, oops, don't do that. All the T's to the left, well, there's 1 T on the left already, minus another 0.6 will be 0.4 T. All the S's to the left, there's 1 already, minus the 0.6, 0.4. What is the operator? Well, not operator, the comparison symbol, let's call it. It's greater than or equal to. Nothing has changed there because I move everything else to the left. And what's left on the right? 0. It's not a formula, Excel. I know what I'm doing. Leave me alone. No. Oh, we missed it. It's okay. Go back and pause it. I will just put it in. B gets a negative 0.6. Excel thought I was doing a formula. Oh, Excel. We just put it in. I'm just repeating it. Scroll back and pause the video while it was there. We'll do it for the next one. T has a 1 minus 0.6. S has a 1 minus 0.6. And it was a greater than or equal to, like the original. And what's left on the right is a 0. All right. Bond requirement. Bond requirement. Well, let's clean it up a little, one step at a time, by going B greater than or equal to, multiply the 0.1 in, so I get 0.1B, 0.1C, 0.1t, 0.1s. Let's see if we can do it in a way that Excel does not freak out at me. Maybe some spaces first. B first, because B is first. B minus 0.1 is 0.9b. Then I'm taking the 0.1c over, negative 0.1c, negative 0.1t, negative 0.1s, because there are nothing else like them. Oh yeah, I just needed to lead it up with spaces. Yeah. I tricked you, Excel. I tricked you good. So I put those coefficients in. Copy it over. Remember to check the negatives. Negatives. Whoopsie, just one. Just one. It is a... I didn't actually finish it. I'm sorry. What is this? What is the inequality? It's a greater than or equal to 0 because nothing else is there. So let's copy these over because they are identical. Haha, silly. 0. Okay, good stuff. Progress. We only need to move everything to the left for Excel because it doesn't know this much variety. It can't think. It's a calculator. Last one. Can we do it on the fly? Yes. B gets a 1. C gets a 1. T gets a negative 1. S gets a 0. There is no S. And we are looking to exceed. And there's nothing left. After I move everything to the left, it's only a 0. We don't put the non-negativity in manually because there's a checkbox in Solver to do that. However, I need to do a sum product, right? Let's maybe use the built-in function builder thingy. Sum product is there because I used it recently, double-clicked on it. I want my variable values multiplied with the coefficients. Done. Drag it. No, I can't drag it down, right? I need to. If I drag it down, this one's not using the yellow numbers anymore. I need to fix the blue selection. Click in it, F4, click in it, F4. That fixes those, whereas the red ones do want to move with me. Check the formula. See how the red moves down with me while the blue stays fixed. Beautiful. That's exactly what I want. Didn't care too much about fixing that one, but you could if you want to. Could fix it. Hey, hey, hey. No, no, get away from me. Get away from me. There we go. We're almost done. We're so close. Let's go get Solver. Oh no, where is my Solver? Did I not? I had it. Something went missing. I have to go find it. In Options, Add-ins, Go. It unchecked itself. Interesting. It's good to know. There it is. Beautiful. It's Solver time. Okay, where's my objective? It's that green guy. I do want to maximize the return on investment. What do I want to change? The yellow numbers. Subject to constraints that we will now add. First constraint, well, first constraint is separate from the rest because in my opinion, it is an equal sign. If you check the answer in the back of the book, they have a less than or equal to. I disagree. I add that one. Next, grouping. These are all less than or equal to until there, right? So we can group them less than or equal to, like so. Left-hand side compared to the right-hand side. Add. These two are both greater than or equal to. Now in Excel, you'll notice here, there is no strictly greater than. because that's weird in the solver. It does weird things. So I should update this guy and group all three of these, make them greater than or equal to. And if I get a binding constraint here, well, I could look at that and do something to it. If I really wanted to, it's not that big a deal for this. We can check that out if we want to. See how the yellow numbers are going to change. I check to make sure they have the non-negativity constraint. But for some reason, my default is always nonlinear. Genetic algorithm. No, I don't want to do that. No, it's not. I don't know what GRG stands for, actually. It's not genetic. This is genetic algorithm. Anyway, I want simplex algorithm because everything's linear. I solve. That was a good sound. Usually it's a bad sound. I can make the error report, sensitivity if you want to, for later, whatever. And there is my answer. I could then write a little sentence, concluding sentence, always very good. Your boss wants to know, what is the answer? He doesn't want to look at the detail of this model. Ew. Just make a decision. Okay, I will. The maximum return, whoops, should probably spell correctly, right? I can spell, I can't type apparently. Maximum return on investment is, that's a large sum of money, 1,805,000, 1.8 million-ish. With the following, let's call it diversification. We could say, ooh, what's that? 1,500,000. That's 1.5 million in bonds. 3,500 and 3 more zeros in certificates. 5 million in treasury bills. Last one, also 5 million. 1, 2, 3 in stocks. I can then check. Let's look at these constraints. Let's look at these. I know this is a binding one. Let's just ignore that and keep things simple. This is an introduction. Let's see. I use all of it. Beautiful. I am well under the bond cap. Well under all the caps except that one, stocks, which makes total sense, right? Stocks is the most profitable option. So it's not that simple, but it kind of makes sense that I would push that to the limit to maximize my return. These guys were not that great in comparison. Don't use all of that. Maximize the stocks. It's not always the case, but it kind of makes sense when it works out like that. I have my requirement here. This is hard to interpret, so I'm not going to. And these are fine. This is just Excel's way of representing a super small number. Don't worry if that looks a little weird. It is still a constraint that is satisfied. And there we go. There we go. We systematically worked through it. Slowly, start to finish. With every new question you do like this, you build experience, and everyone gets easier after a while. All right, the next one we're going to do should be somewhat familiar. I'm going to do 2.8. Unfortunately, it's also starting at the bottom of a page and continuing up there, but whatever. It's all good. Again, now how do I read this? I read it, but I don't read everything with the same attention. We want to carry out a survey. and interview at least 5,000 respondents. In addition, the following requirements must also be met. Don't care, don't care. I care about what? I can't start if I don't know the objective. Constraints mean nothing to me right now. Costs associated with interviewing respondents of different ages in Norwich and outside is there. So now I look at this table and it says, okay, there are 3 different age groups. It's a little typo here. What happens if you're 50 and a half? You're not in this age group, and you're not in that age group. I assume that you would want to span the whole age range, but whatever. Anyway, we have 3 age groups. Maybe they don't. Maybe they don't like 50 and a half year olds. And for each, we distinguish between people living in Norwich and living outside. So, looking at this, there are different costs for 6 different groups of people. Okay. Again, at the end, they give me what I'm looking for first. The survey should be completed at a minimum cost. Minimum cost. Write that down. Why not? What is this? 2.8? 2.8. I should put the answer report after a question, right? For the previous one. Anyway, we wish to minimize the total cost. That's a sentence just for me to help me. What is first in the formulation of the model? Variables. Variables. Now you can define these variables however you want. The point is I need 6 of them. 1 for each group of people. So I'll choose N and O for living in Norwich and living outside. And then the age groups, I'll just make U, V, and W. So, again, this is my choice. Choose whatever you want. But I want to have a variable name that is somehow going to help me remember what it represents. UN represent the number of people. Always a number. If you say it represents the people, no. The variable does not represent people. It represents a number of people. What's the first group? 30 or less. 30 years or younger living in Norwich. Let's say UO represents the same age group but living outside. Now I'm not going to write this down every single time. That's stupid. I need 1 for outside, then 2 for the other age group, then 2 for the other age group. There we go. Now I just edit it. UO represent the number of people 30 years or younger living outside. Next one I'm going to make is, let's say, VN. Represent the number of people 31 to 50 living in Norwich. I'll just copy this one over. The wording's different enough. VO, same age group, living outside. I'll call the last age group W. WN, represent the people 51 years or older living in Norwich. Copy that over. Boom, boom. WO, same age group, but outside. There we go. Obviously 6, because I cannot calculate the cost if I don't have the number of people for every one of these table entries. I need to split them apart because the cost is different for each group. Okay. Now I'm ready to write my objective function. Minimize the total cost. Let's call it C, where C equals. I don't know. Can I minimize this? Not that small. That's way too small. There we go. See the table next to it. There we go. Beautiful. Okay, C equals, well, if I am surveying UN people and it's $1.53 per person, the cost from that group will be $1.53 times the number of people. Age group but outside of Norwich, 1.4 or 40, it doesn't matter. Number of people in that group. Keep going. Next age group living in Norwich, that will be VN. So 1. Oops, I am not in my Excel file anymore. 1.38 VN. The cost associated with this age group but living outside of Norwich, 1.47 times the number of people, which is VO. No, VO. That is this one. Last age group, 1.12, $1.12. It's not a dollar, I know it's a pound, but 12, I said 12. Don't type 13. Age group is the last one, so that's WN. Last one, 129, WO. All right. I needed those different groups, otherwise I could not calculate the cost. I then defined variables to represent the number of each of those groups. Call these variables something else, that doesn't matter to me. Now I'm paying way more attention to the constraints. I think we can keep doing this side by side. Sure, zoom out a little. Oh, it's okay. Yeah, we can still see it. Okay. All right. We want to carry out a survey and interview at least 5,000 people. So the total number of people surveyed will have to be at least 5,000. How do I calculate the total number of people? I add up all the variables. All of these people, plus all of those people, plus all of these people, plus all of that group, plus all of this group, plus all of that group. All of them must be at least 5,000. Let's give it a name here. Total respondents. Done for that one. Now I keep going. What else is there? Bring it on. At least 2,000 respondents must be 30 years or younger. They keep phrasing these things in the other way around when I compare it to my inequality. Fair enough. I mean, this is the English language. This is the mathematical language. It's just a translation issue. You get many languages where the word order is different. It's no different here. 2,000 people, at least 2,000 people should be 30 years or younger. Rephrase that. The number of people that are 30 years in the 30 years or less age group should exceed 2,000, well, should be at least 2,000. How many people are 30 years or younger? Those living in and those living outside of Norwich. That has to be at least 2,000. So let's say young people requirement. This description is just for me. So rephrase that until you have the direct translation to the inequality. At least 1,200 respondents must be between 31 and 50. So the middle age group must be at least 1,200, or must total at least 1,200. How many people are in the middle age group? Those living in Norwich, those living outside of Norwich. At least 1,200. Middle age requirement, or whatever you want to call it. Hopefully we're slowly getting the hang of this. Hopefully. I don't know. That's up to you. You have to come and tell me if you don't. I cannot guess. I cannot guess. Okay, these two are tricky. Slow down. Be careful. At least 12% of the respondents must live in Norwich. 12% of the respondents. Let's fill this in slowly. How do I represent 12% of all respondents? It'll be 0.12 times all respondents. Let's start to write that in. 12%, 0.12, multiplied with the total. Now I'm going to cheat because I'm lazy. I already have the total here, don't I? 2 U's, 2 V's, 2 W's. There's no need for me to type it all in again. Let's put it in there. Paste. I'm not done. I'm trying to translate a part of this. 12% of all respondents. Those that live in Norwich must be at least 12% of all respondents. What is the number of people living in Norwich? I'll just put some spaces here. Well, it's the young people living in Norwich, the middle-aged people living in Norwich, the old people living in the city. They have to be at least 12% of the total. And there we go. I'm going to move this a little bit to the right so that I avoid overlap. What is this requirement? The Norwich requirement. That's a tough one. Yeah, here's another one. Less than 20% of the respondents who are 51 years old or above, so that means old people, according to this, young, middle, old. Less than 20% of the old people must live in Norwich. Let's just represent some of it. How do I represent 20% of old people? Not to discriminate, but they made the age groups. I'm just trying to say it in an efficient way. 20% of the old group. Well, who's old here? The W's are old. So that represents 20% of the old group. Must live in Norwich. Less than 20% of the old group of people must live in Norwich. Rephrase that. Of the old people that live in Norwich, it has to be less than 20%. So these are specifically referring to the old group. Of course, some are going to be living inside the city. Some of them are going to be living outside of the city. Those that live old people. Those that live inside the city must be less than 20% of all the old people. How many are in the old group and living inside the city? WN. Less. Now I know we don't have a less than in Excel, but in our formulation we can do whatever we want. Tough one. Let's say old and Norwich requirement. I don't know, call it whatever you want. Last, I'm at the end there because then they started talking about cost. I just have my inequality, my non-negativity, where painful as it is, type them all in. Whoops, UO, VN, VO, WN, WO. At least 0. What is the name of that inequality? Non-negativity. Done. Think about these last two. If you're struggling with them, we just have to go really slow and say it over and over and try and rephrase it in a way that would fit with the phrasing of this inequality. It gets better with time and experience. That's all I can really tell you. The struggle is worth it in the end because every question you do, every translation you do, it gets easier. Think of a language. The first time I try and read a language, let's suppose you're learning something new, right? First time you read it, it's incredibly slow and incredibly frustrating. And you feel like you will never be fluent. You will never read this. Yet, there are billions of cases. Everyone learns to read. How many learn a new language? Eventually, you read it so easily and translate it between languages, and you think back, how did I ever struggle with this? It's all a matter of where you are in the journey. We're done with this. Let's go to some Excel. Good times. All right, for Excel, I need my variables. This is how I do it. Yours don't have to look exactly like this, of course. UN, UO, VN, VO, WN, WO, and that's it. Then I will have the values here, variable values. Don't know what they're going to be. I will make them all 1. Simply to check if the formulas work. I'm just paranoid. Am I actually recording this? Yes, thank goodness. I'm always paranoid. Am I recording this? Because this is a lot of effort. And if I didn't press that record button, I am going to cry. Now I'll do the objective coefficients. Where are they? They're up here. It's been a while, but they're there. 1.53, 1.4, 1.35, 1.47, 1.12, 1.29. I can do it this fast because it's in the same order. I'll put my objective function value over here. Nice pale green. We can call it C for cost. You can type it in manually. You can use the insert function. Why not use the insert function option? It is so easy. Coefficients of the not coefficients, I'm sorry. Values of the variables, coefficients in the objective function. Boom. What does that 8.16 mean? Absolutely nothing. It's just a temporary check to see if the formula makes sense. Then I have my objectives. No, I have one objective. It's done. My constraints can go over here. Let's just try and see everything like so. All right. First one's not bad. everything gets a 1. Then a greater than or equal to 5,000. Okay, that's pretty straightforward. While I'm here, maybe we'll calculate that. Why not? Blue. I'm looking for blue. Maybe this time I want to just sum product it. Whoops, no, sum product. Not some product. I want to put that guy and fix it with this guy and not fix it. Show you again. Pause there if you want to. All right, the young people requirement. Oh, that's a pretty good one too. All the variables are already on the left. Easy peasy. UN gets a 1. Maybe this time there's a lot of zeros. Maybe I don't want to write all the zeros. Totally fine. I'll show you. It's fine. Leave them empty. It's not a problem. Drag my formula down. Double check. It's doing what it should do. Beautiful. It is also a greater than or equal to. In this case, 2000 is the right-hand side. The middle age requirement, also a very nice simplified inequality already. It is, I shouldn't do that, like this, one thing at a time. Check the formula, beautiful. It is also greater than or equal to, what is the amount of the right-hand side? Just 1200. Okay. Now the two tricky pickles. Let's do it. Clearly, I need to simplify this inequality. It's ugly. Let's do it in steps. I'm actually gonna do nothing. I'll just write it again. UN plus VN, the right-hand side, is already pretty simple. It's, sorry, the left-hand side. The right-hand side needs work. 0.12 multiplied in. Whoopsie. 0.12 multiplied in. 0.12 multiplied in. Yes, indeed. It is super tedious. But if we're not sure, we have to go slow and see all the detail. There is no shortcut to understanding. Whew, that was annoying. Now let me just merge this right in here. Why not? Why not? Rewrite this if you want. Move everything to the left. I think we can handle it. Coefficient of UN. That's this one. And a negative. 1, 2. So it'll be 0.88. UO does not have anything on the left. I'm just moving that one over. Negative 0.12. VN is already there. 1. Take that guy over. 0.88. VO is not there. Move all the VOs over. Negative 0.12. Don't notice a pattern. No, don't notice a pattern if you're not ready. WN, 1 minus 0.12. WO, not there. Move that over. Negative 0.12. Did I? Yeah, I said it right. Check the formula. Beautiful. What is the inequality? It is again a greater than. What is the right-hand side? 0. There is nothing left after I've moved everything. One more. We're almost done. I can see the end. It's so close. This one's easier. But a rewrite might still be helpful. 0.2 times WN. 0.2 times WO. Let's do it. WN and WO are the only variables here. The others are all zeros, which a blank cell would be, in this case, read correctly by solver. WN, 1 is already there, minus 0.2, 0.8. WO, nothing is there, only this guy moves over, negative 0.2. Copy down the formula. It looks good. What is the inequality? It is a less than. I know in solver I would have to make an equal an option. What is the right hand side? It is a 0 because there is nothing after I move it. We made it. It's solver time. Let's do it. Come to me, solver. I can't see everything, but that's okay. Click on this little arrow box here on the right. That helps me to go and choose whatever I want to choose. I want to minimize the cost by changing the variables in the yellow cells. Yellow for me, maybe not yellow for everyone. Add some constraints. Okay, let's do it. All of these are greater than or equal to and can be grouped together as long as you switch the sign, the inequality. All the constraints are there. I want to add another one, which is this last one. Less than or equal is all I can do. There's no strict inequalities in solver. And a 0. That's it. Check the box to make the non-negativity constraint apply. Simplex, always with this non-linear. No, it's linear. Simplex. Do it. Go. Include the answer report if you want to. Sensitivity report if you're interested in the next topic. Doesn't matter. There it is. Boom. What's missing? A concluding sentence. Wrap up your problem. We started with words. We chose this linear programming route to find the answer. We finish in the original language, English. All right, the minimum cost is, it's pounds, right? 6680.80 pounds. I don't have a pound symbol in Excel. By surveying the following number of people. 2,000, age 30 or younger. Don't be lazy here. Concluding sentence, wrapping up your answer, super important. Invest the time and write full, clear sentences. 2,000, age 30 or younger, living outside Norwich. 1,200, age 31 to 50, living in Norwich. 360, that's a 2, 360, age 51 and above, living in Norwich. 1440, age 51 and above, living outside Norwich. Ding ding, we are done. There we go. Practice, practice, practice. Trust the experience building procedure. It works. Just do more. Every time you do a problem that's a little different, your experience builds, and eventually it's not going to be that hard. It's the only secret. There's no secret. It's the only recipe for success. Let's move the answer report to the back because it is more proper. And let me know if you have any questions. Until later.